Hello everyone and welcome to the Autodesk Robot Structural Analysis tutorial brought to you by the Civil Engineering Essentials channel. I hope you enjoy the video. In this video, we are going to finalize our project, which is the lattice steel structure, by designing the elements and producing some reports. Of course, this is in no way or shape the end of lattice steel structures, but this video series for lattice steel structure serves as an introduction to the topic so that you can build upon using more complicated models for those structures. Okay, so there was one little discussion with our dear subscribers, Donald Khani. He mentioned rightly so that I have forgotten to release those things, and he's right. And to prove his point, I will show you the bending moment diagram very quickly. So if you go to diagrams for bars and y, you can see that those elements do have moments around the y and z and all kinds of axes, which means that those were not released. So how do we do this? Well, the only thing we have to do is to select our members by group, and we did group last time, so I think this is easy to select now. So if you double click here, click on refresh selection, you see that the selection has been done. Now I'll go to geometry, go to my additional attributes. I can assign truss members or I can assign releases. For now, I will assign truss members. There was another discussion about truss members. Already subscriber Donald Khani also mentioned that if you use truss members, you will not see the bending moment diagrams. So I don't think that this is right for this member because there is a bending moment diagram because there is like a connection in the middle. So this doesn't even work. So following Donald Honey's advice, I'll go to releases. So geometry release, and I will have it pinned. So if you apply that, it will tell you it changes, yes, and I think everything is fine. We can run the analysis very quickly to double check that, but I think that the structure is still stable. So yeah, it is stable, and of course the behavior changes a little bit, but it still is what it is. If you go to results, diagrams for members, MY and MZ, you can see that you now have simply supported moments only on the middle, but in the ends you don't have moments because in the ends you have released those elements. Now you would think, why should I even care about this? You care about this because it has an effect on the connection that you will be designing here, because the connection you will design here is basically a pinned connection rather than a fixed connection. Now, truth to be said, Robot is really good in designing connections for normal trusses, but for those trusses, it might fail miserably. So anyway, enough of this. Let's go to the design. Well, how do I go to the design? Well, I simply go to design, steel member design, and I activate the design interface. Now here, of course, you can check members and select groups and whatsoever. There are no groups here, strangely. You would think that you have defined groups, right? I mean, if you go back, let me remind you, you had groups here, those V thingies and truss diagonals. So it seems to be strange, and it is strange. New group here. Now this is a design group. The name is going to be V thingies, which is awfully identical to the group of the selection group. You see, those are design groups, and the ones that were here were selection groups. There is a difference here. So how can I select members in that group? Now this is easy because I can go here to the selection and I can still select my selection group. Now this might like confuse you, but if you click here and say select, you can see that the V thingies got selected, and you can now move the V thingies from your selection group to your design group and save that group. So now you have a V thingy for the design and a V thingy for the analysis. This will continue, so this is my group number 2 now. I'll call this horizontal square. You see that I am basically repeating everything here and trying to use similar names because I want them to make sense. I'll just select here my square elements. So first of all, I'll clear the selection and then I'll select this. And you click here, it gets implemented. I'll save that. Now, one thing I forgot, I will do this very quickly, is what kind of section do I want? So even in group number 1, I forgot to determine what sections I want. So if you go to sections, you can see that you can select what types of sections should be used in the design of those elements. We go to the next. You know where this is going, so I'll quickly video edit this. Okay, so one thing before we start designing, I realized I messed up. When I was doing the sections while video editing, I was using DL, which is double legs. I don't want double legs, I want simple legs. So if you click on the leg now, this is the L. So this is incorrect. I have to modify my sections altogether. So I delete that, select my L section now with AISC, and select them. So I have to do this very quickly for all the sections and save again. So back to this. My sections were incorrect. I was using double legs. I don't want double legs. I want single legs, which is L. I'll very quickly change my sections. Not double L, but single L. So AISC, L section, L. Okay, save. And group number 2, sections, delete all. AISC, L section, select the L, and you have it. Save. And finally, the group number 1, same thing. I'll go to sections. I'll go to AISC, L sections, select them all, and well, say OK. So now I have everything. So okay, the first thing is we want to design our groups, your 1 to 5 groups. You can click on list to see that you have your design groups. Now we want to design them and we want to optimize them to select the smallest weight, because that is what we do usually in steel structures. We want to design them for the ultimate limit state. So well, we select all those equations to be included in my ultimate limit state. And I'll start me some calculations. Now it starts calculating the best section. And let's take a look on the results, which is going to be a little bit interesting. This wouldn't be a CEE channel if I just don't give you some ideas about what I see here. So, okay, what do we see here? Well, we see the following. First thing we see is that the elements are chosen okayishly. I'm usually afraid when I see elements chosen from the far reaches of my sections. What do I mean by far reaches? I mean this. You see the smallest section for L is 2 by 2 by something, and the largest section is 12 by 12 by something. So I usually get worried if I see 2 by 2 and 12 by 12, because it means that my sections were like either under-designed or over-designed. So I mean, look here, this is 10 by 10, this is still acceptable, and of course those are the main chords. Okay, this seems to be something I have to talk about, so let's click on that. Those are the truss diagonals. It's using 2 by 2 by 0.1875, which is a section on the borderline here. It's almost the second smallest section. So it makes me like ask some questions. Well, what are those truss diagonals? Now, luckily for us, in this case, the truss diagonals are actually those things, those little things, because those are called the V thingies. So yeah, I think it seems that it's using the smallest of sections, but I still can let it pass because, I mean, already the only force you have here is the force due to um, cables, and it was able to withstand them efficiently, I think. Still, if you feel worried, of course, you can select the stronger section, but well, this section suffices. So, no worries there. Now, the second thing I want to talk about is look at the case that was governing the design. Because we are trying to design a failure containment structure, all the elements were governed by the failure containment load case, which makes sense because this is one of the extreme cases. And I want to quickly remind you that, well, this is a case that should be considered not for all towers, but for just some of the towers. Anyway, this is the design, so I'll change all, first of all, and then I will redo the calculation. Because when you change sections, the internal forces change in turn. So I have to recalculate again and do another design iteration. Okay, there is a connection. Yes, it just tells me that there was a connection because I have prepared a connection to check out with you. So this is something that you don't know for now during my video editing. So this is a small and harmless error. Now I'm gonna redo my design calculations again because the section changed. And well, it seems we have some new sections. So I will change all over again. See, you have to do this multiple times for iterations. I iterated it again, I closed that again, and redo my calculation to recalculate the internal forces and calculate the newest and best section. So I'll select my new sections now. I close that, change all, yes, and calculate again the structure. And that's that. That's all I want to do now. So I think I'm finished. Of course, you can go back to code check or code group verification just to make sure that your sections are adequate. You see that most of them are adequate, but here you have an error, it seems. And let's take a look. It is, what's the problem here? Let's take a look. Instability. Why is it unstable? Yeah, okay. You see, your LCS over RZ is 201. It's more than 200, which means it's unstable. Now, truth to be said, I would let it pass, but well, no. Why let it pass? So we can basically retry again. So okay, design and change all. See, this becomes a process actually. I'll run the calculations again. And I think that's that. I don't think that I will do again a refresh of my calculations. And you can see that all of them are in fact okay, so we have designed. Now, of course, we finished our design of the members. We need to produce meaningful calculation notes. So how can I do that? Well, you click on the member you want, you click on calculation note here or calculation note here, both of them work. If you click on this, I want a full note, and you click, you get a note that is an RTF file. This is an RTF file. You can file save it as, and you can save it wherever you want. This is an RTF file, a rich text format, which means it's openable in Word. So, well, you export the design report of each and every member using the calculation note button to export the calculation note so that you can show in your report that your cases or your structure is verified. That's not all, because this is the design report for the structure. However, I like to make a report for the analysis of the structure. So how do you do that? Well, first of all, you go out from design by going to start here. Let me show you how I did this. So I was in the design GUI. To go back to your analysis GUI, you click on this and say start. So it goes back to the start GUI. Now, you can make a report on the structure itself. So what do you need? Well, you need some pictures, right? So you click on this, the structure presentation, and well, you might be interested in taking some pictures of the structure, some screenshots. So you can click on this, which is called screen capture. It gives you a little thing here which you can ask what do you want to show. Well, I just accept now, okay, just now. And you can also change the angle, do whatever you want. I'll keep it like this. To produce the calculation report, you can go to File, Report, or Print out Composition. Here, you can, of course, go to Templates, for example, and let me just quickly delete this stuff. You can select from predetermined templates. So for now, I might want to see the data of my structure, so I click on Data and open it. So it adds the titles here. Okay, there is. You can also add the steel timber design if you want and add it, and then basically ask it to print out by saving it. So, well, if you save it, it tells you where you want to save it. You click on save, and you get a report. I will not click on save because it takes time, to be honest. I just opened the report I produced for you while I was video editing, because it's just a time thing. It takes a lot of time to produce those reports. Anyway, this is the reporting of the analysis and the reporting of the design. There is one thing that remains, which is the connection. I know this video seems to be really short, but it is. It is the 5th video, and I hope you have learned a lot in this video series that might warrant you to give it a thumbs up and subscribe, to be honest. Still, so basically this video is almost a formality. But, well, let's take a look. Now, this is the design report. You can see all kinds of stuff. Picture I took, the members, the steel stuff. It's all kind of nice and dandy, and you can take a look on it yourself. All right, so the last thing I want to do is connection design. So, well, if you go here, now Robot is good in connection design if you know how to select those connections. You want to design this connection. Now, you cannot simply select those members at all of them. It doesn't work, because this becomes a 3D connection and Robot doesn't know how to deal with this. There are still softwares from Autodesk that are capable in dealing with two-dimensional connections. I mean three-dimensional connections. But in this case, we only have robots, so we can only do two-dimensional connections, meaning connections that are in a plane. So, for example, I want to select, let's say, this element, and this element, this element, and this element. Now, I'm not really sure if it works because this is a continuous element, so it might not work, but well, it's worth a try. So design, steel connection design. Now, this is a previous connection I have just tried my luck with. Now, I want to go back to my structure. Those are my selected elements. Let me see. Where is my elements? Those are my elements. I should not have selected this. Wait, let me just delete that. Okay. Now I've selected some elements. I can click on new connection from selected members. I hope it works. I don't know. I think it does. So it has made you August. Oh, it did. Wow. I'm positively surprised. Like, it even understood that this is a continuous bar. This is next level. Now, of course, you can play around here, but I will leave it for you because it is really code dependent. So please check out your own code. But you can see that you can basically input the type of connection you want, be it welded, be it bolted, and of course the code bar if it is what the section is. Now you cannot change the section here because the section is taken from the structure, and this is the beauty of it. For the diagonals, once again, you see the diagonals defined, and you cannot change the diagonals because, once again, the section is taken from the design. I don't think do we have a post? Yes, we have a post. Even the chord connection, we have one continuous chord. We can thread the chord. Even the gust plate dimensions can be decided. Is it okay? Let me just check. I think the gust plate is too large. Let me see. If I say apply and say okay, if I go to connection view, yeah, the gust plate seems to be large. Now, this is a limitation in Robot. It doesn't flip. It doesn't deal with the sections correctly. Like it just says here are the two bolts that you need. So, although it looks cool on paper, I know. I mean, I could brag about it that it's being amazing, but it's still a little bit limited. Now, although it looks cool on paper, it tells you okay, it looks cool, but truth to be said, it's not really that amazing. Why? Because you see, the connection here is actually not what I was planning in the beginning. I was planning that this goes all the way through the lower chord, this goes all the way through the lower chord, and there is no need for gust plate. I was planning to connect the diagonal with the lower chord directly, and the vertical or post with the lower chord directly without a gust plate. And that's the reason why I had the gamma angles. So it doesn't do that. Robot doesn't understand this, and well, for good reason, because this is really technical stuff, and Robot tries to be a multi-purpose software. So it really is kind of against what I want. But still, how can I use those information? Well, you can use this information by knowing how many bolts you need and what the spacing of the bolts is. For example, now this is a practical thing now. You see that those truss cords are actually small. Now, those truss cords will not fit the two bolts if you want to connect this member with this member. And this is where you need hours to finish this. It takes a lot of time and a lot of tries. Let me show you what I mean by this. If you go back to structure and go back to your start and go to your design once again. So let me go to my design. Let me just check those members. What were they called? Were they called truss cords? Yeah, they were called truss cords. Okay, so now let me explain to you something very practical. Those are the truss cords, and it seems that I need larger truss cords so that the connection makes sense and that I can, because I'm planning to connect my members here, not to a gust plate, I'm planning to connect those members to the cord directly. So there is yet again another consideration for the cord now, besides weight, which is the accommodation of the bolts from this element to this element. Now I hope you're following me with this because it's really a little bit confusing, but it is rewarding. What I'm trying to say is look at the connection view. I want this to go through the lower chord and have the bolts on the lower chord. Now, Robot will not do this for you, by the way. But from the calculation, I know that I need two bolts here. I know that I need two bolts here. So my goal is to shift this inside the lower chord. So I need a bigger lower chord to accommodate the bolts. That's my plan now. So if you go back to structure model and to the design, which is the truss cords, if you go to design, steel member design, well, you see that the lower chords have been, where is it? Where is it? I forgot what the group was. I think it was group number 3. No, 4 truss cords. Yes, group number 4. You see that group number 4, if you want to just verify that, from the design perspective, group number 4 was perfectly fine with those elements, 3 by 3 by this. However, from practical reasons, this is not enough. So now I know what the minimum requirement for the truss cord is, but I don't want to design it. I want to force a certain section on truss cords 4, and then I want to make a verification only. So how do I do that? Well, you can design if you want. Actually, you can try this. If you put maximum section height or minimum section height, let me try this. I want minimum section height to be, okay, it was 3 inches. Let's say I want to have 30 centimeters or maybe 20 centimeters. So around 8 inches. I will just put 200 millimeters here. I just want to try something if it works. So now my criteria is minimum section height and weight. Of course, I'm not going to design all the elements because they work. The only thing I'm going to design now is group number 4. So if I do calculations now, I hope it works. No, it doesn't, right? Yeah, it doesn't. It doesn't understand this. Wait, okay, let me click on optimization again. Calculation. It does it? Oh, it does. Got for you L8 by 4. So, okay, this seems interesting. This seems promising. I'll change all. Close. And calculate again. And now I want to go to my connection. It should tell me that it updated the connection, right? Yes, it updated the connections. Perfect. So let's go to the connections now. So steel design, connections. Well, this got updated, but this didn't. Okay, let's scrap this and go back to our structure. No, it did update it. Okay, so we can just select them, right? So, okay, let's select them. 1, 2, and 3, right? Create a connection. Let's hope it works, right? So let's take a look. Oh yeah, fantastic. I think, yeah, it makes sense. Of course, you can calculate the connection. It will be safe. Trust me. And you have enough space here to put this inside this. So yeah, I mean, it seems okay-ish. You don't need the gust plate, by the way, because you can connect those elements directly to the element here. You can go to results to see the elements. Of course, you need to calculate that. So, well, calculate me. It takes, now how does it calculate it? Well, if you click here, if you click on manual, you can input your loads yourself, and it takes the loads from the analysis. If you click on automatic design, it will take the loads from the internal forces from your analysis. So if you click OK, it designs it, and it tells you here is my design calculation, which is amazing. It is amazing, all the verification it does. And it conforms to the code. Now, what would I do? I would basically take this, export it, and then I would basically change a little bit with those arrangements because I don't need a gust plate. The last thing that you should design is, well, the foundation. Now, I need to make some advertisements to other videos to make them a little bit more clickable. So you can check out a video that is linked above on the design of foundation here. Of course, I will do it very quickly for you here, but this is going to be really quick without a lot of exposition because there are videos on that regard. Well, let's select this one, for example, go to design and say, well, I want to go to my RC element design. All right, so it takes time, of course, and I think something's missing in Robot here, right? It's installing something. That's odd. I mean, I'm not making this up. It wants to install a feature here. I'll just cancel that. Okay, it seems my robot has a problem. Is it working now? I have to investigate from my side. It seems my Autodesk Robot has a problem, to be honest. Well, it seems my robot have a problem, so I will leave the foundation design for you. As much as I wanted to do it, but, well, robot is not cooperating. I have to uninstall it and reinstall it again using my... Yeah, see, it's just popping up randomly now. Uh, I will leave it without video editing, to be honest. It's just funny that it just starts spamming me with pop-ups. It's like being virused or something. Anyway, uh, well, basically this ends my video for you today. It's kind of a short video, I think. I'm expecting it to be like 20 minutes or something. So, well, I hope that you enjoyed the video series with regard to lattice steel structures. I personally have enjoyed it. I think that you have now a solid background in those structures. Of course, you can improve upon my work with your own ideas. And feel free, of course, to comment, like, share, and subscribe if this video was beneficial for you. Especially subscribing because it increases the reach of the channel and helps me immensely. As per usual, this is the Civil Engineering Essentials channel, and we will catch you in the next video.